Okay, welcome to our session. I do apologize for the title of our session. It was supposed to be a pull quote, and somehow it got drifted into the title. So I think we're talking about falling off the edge and having a good experience is what we're retitling it to. So it's a little shorter. I have an amazing panel of folks here, and any one of them could entertain you for a full hour. But we've all gone on here from them all. So what I've done is I've asked each one of them to do a summary as quick as in 5 minutes, and then we'll have them interact, ask each other some questions, because I think that'll bring up some interesting things. And then we're going to open it up to the audience. And if you would be so kind as to come up to the speaker, because Eric is filming all of this, and we would like to catch your comments, because we find that the comments from the audience are a big part of what we do. And I've also asked each one of the speakers to just do a quick introduction of themselves, because most of them wear so many hats that I have no idea who they think they are, so they can tell you who they think they are. And starting with that, a man of many hats, Mark Peacock.
Thanks, Ken. I wear many hats because you can see I'm losing my hair more and more each year. So, my name is Mark Peacock. I'm the Chief Marketing and Communication Officer for LinkSpring and Connects. That's my day job. My nighttime job is I'm one of the executive board members for Project Haystack, which I'm sure many of you have heard of. I also try to write a monthly column for Ken on stuff, basically gives me free rein to write on. And I serve on the board of directors of Connects Energy and a couple other companies and a couple nonprofits. So we're here to kind of talk a little bit about the edge and stuff like that. From my perspective, the edge is here, and it's here now. It has been here, and it's been here for at least the last 2.5 to 3 years. I think many of us in the industry don't realize that it's here. So what's really driving us to go to the edge, or where the edge is? First and foremost, we look at computer processing power and the power that is now in our controllers and how powerful we can make our controllers. Second, and I think truly is the quiet driver behind the edge, is data followed up by analytics. It is now, I think, where our technology has taken us, is being able to process data at the edge. In addition to the cloud, if you want to send it up to the cloud, but why not process it where it is happening? Equally, we talk about all this controllers and the technology and things like that. A statement that John and I have kind of used together is that the data is now more valuable than the device itself. And I think that is becoming more and more true each and every day as technology continues to evolve.
That's a big statement.
It is a big statement. Save your comments after we all done. Yep. Data, again, data is more valuable than the device itself. Equally, we see with the respect of, or at least what I see, that with the edge, that we are able to do real-time analytics faster, and again, at that level, plus the opportunity in which we can do more in a more secured way, because you're not transmitting data up to the cloud as much. Where we're seeing it is in both retrofits as well as commercial construction, new commercial construction, excuse me. I think the how many building owners are here? Let me do a quick poll. Building owners? A few, good. Engineers? system integrator contractors. You should have done this one, Ken. All right. At least give us a kind of view. In conversations with building owners, we are hearing that they are looking at, well, what are we doing with the edge? Can we get on the edge? I'm seeing middleware, it's there, but it's kind of coming in the background now, especially with the push of IoT technologies. And I think that's a quick little summary of where I see the edge is. But again, the main thing, the takeaway is it's here and it's here now.
Thank you very much, Mark. Okay, our next speaker, Trevor Palmer, has, again, a bunch of hats, so I'll let him tell you. He told me he's just living in an airplane now, or no fixed.
Yeah, so I usually introduce myself as Trevor Palmer, Delta Airlines. So, the real home. I'm with QD Brands, Distech Control, so I'm basically a resident geek, product manager. Kind of straddles between BMS and the lighting world and, dabbles in this new thing we're calling IoT. You see, almost every booth out there has a sign. So, I guess I'll share with you some learnings rather than kind of sticking to somewhat of a script. So what I've learned over the past year is I've gone out and I've spoken to customers, and my customer base, I'm from the BMS world, so my customers were system integrators, right? So I was trying to make them more efficient, deliver solutions with better installed costs. That was kind of the recipe, the holy grail, if you will. If you can make those guys really efficient, there's lots of you in the room, you can deliver these jobs faster, right? And you can hopefully make a little bit more money and go on to the next job. So the world we're in now is a whole lot different, right? When I started in this industry 20 some odd years ago, can you believe I'm saying that, Ken?
What year was that?
95.
Okay.
So I started actually pulling pneumatic tubing on jobs, right? And I get asked by whether it's one of the leaders, business leaders at Acuity or any end customers, well, what's the benefit? What is this IoT? What does it mean to me? What does that mean really? How's that going to affect my business? So I'll share this learning with you. So, when we first started talking about IoT, and we had delivered this kind of network of very powerful controllers that were effectively embedded PCs that were 10 times more powerful than what we had sitting on our desks just 5 or 6 years ago. You try to explain the benefit of that is, well, you're putting more power in your building on a building controls network because eventually it's going to be more, right? So you get the question, well, what is it going to do? What exactly is this going to do? And it's kind of the same thing in the lighting world. What is this going to do? Well, so eventually you started building out these applications, and these applications were not necessarily connected directly, a direct benefit to the system integrator or the building right away, but they were outcomes for the business that we're operating within the building. So what do I mean by this? So if I was to go and see an educational customer in an educational vertical, and see the dean, does the dean care about how much energy per square foot the facility is using? Now the answer is no, not really.
They all do.
Well, they can, but really it's a facility management staff that are driven by that key performance indicator for the building. They're striving to use less energy per square foot and make things greener. The dean really cares about educating students, right? They want to drive students in, attract students into the building, they want to drive students out, and they want to make that happen as efficiently as possible because their business goal is to generate more funding for the university through research, but also through tuitions, right? So they really care about that. So, you start to ask yourself the question, well, how do we tie that back to building systems? Well, this is an interesting thing. So I'm in the lighting and building systems world. So if we take that right down to a lecturing hall like this, if there was a massive amount of CO2 in this space, we'd all feel really tired. It wouldn't just be my rambling on that would make you guys fall asleep. You guys would feel really drowsy and really tired. So having the appropriate level of CO2 or a very low level of CO2 in the space and controlling, the fresh air helps you win kind of the trifecta of energy, comfort, and keeping people awake. So we're starting to drift into making the space more pleasant and connecting that with the institutional goals of the facility, right? Making the dean happy as well. So that's good. That sounds great. We've been doing that for a little while. But what about when we tie kind of lighting into it, right? If this is, instead of just a lecturing hall, if this is, a meeting room, what if you could use the data exhaust, and we talk a lot about data, what if we could use the data exhaust not just to turn the lights on and off in the occupancy sensor, but what if we could find out all of a sudden from that same infrastructure, is this room occupied, or how often is it occupied, right? So that satisfies, kind of a different persona in the building, or a different stakeholder in the building that might not have anything to do with temperature controls, right? So this idea, when you try to quantify to people, whether it's a building owner or a systems integrator, any of these guys, well, what does the IoT really mean? Well, it really means, keep doing what you're doing in terms of deploying these systems, but when you're guiding building owners or facility managers who are making these decisions, or indeed consulting engineers, start to think about not just what the killer app you bought the system for, right? Comfort control or energy savings. Start to think about what you want this infrastructure to do in the future, right? So we were just yammering away here about the iPhone and Uber. So think of it this way: Uber didn't exist before the iPhone existed, right? Moreover, Uber is enabled by the Blue Dot, the GPS Blue Dot technology, right? Among a bunch of other things, right? You can't have one without the other. So you got to sell it forward a little bit, and you've got to explain, you got to understand the use cases of the facility itself, and then tie that back to the types of systems that you need to put in, right? So I thought that would be appropriate for this.
Were very clearly distinguished between lighting and HVAC, and it was this rare unicorn that sort of melded the two together. And we started slowly to see that a handful of integrators were realizing that the benefits of bringing these two territories or these two independent silos together into the same platform, and in some cases even under the same contractor, was really interesting. And so over the past, even the last 3 years, there's been just an incredible acceleration in seeing these two silos come together and coalescing into this whole building solution. And a lot of it is the drive to connect these more independent pieces together is coming back to the data that Mark and Trevor mentioned. Of course, that's me. Sorry, guys.
Data coming in.
Yeah, exactly. So I apologize for that. So these sensors and switches and different things that are providing the data and feeding the information in is an interesting thing, because evidently that our industry, we provide wireless sensors and switches and different pieces to the industry. We've evidently been searching for a name for a number of years, and finally the Internet of Things has finally given us a name, and so that's really felt pretty good. So we've been doing the things for quite a while, and we've done things all along. So the IoT is becoming a bigger part of our lives with the advent of Alexa and IBM Watson and Google Home and all these different artificial intelligence and virtual assistants helping us out. It's really becoming part of our daily life, and I don't think it's really drifted into the building sector just yet. It's on its way, and the infrastructure being there will help kind of lead it towards implementing that in the future, sort of selling it forward a little bit. And one sensor by itself is kind of an island. One sensor connected to data analytics or an artificial intelligence assistant is a meaningful contributor to a huge variety of parts of the system, right? So we can do the simple things with the data. We can do occupancy sensing and turn the lights off and do that, and we can do a lot of things that Trevor mentioned as well, where we're actually making the building more useful. We're seeing a lot of our implementations now are using occupancy sensors to create traffic maps and heat maps, and actually utilizing that in their real estate asset management portfolio. So they start to look at how these different spaces are used. Why is space number 1 used once a week and space number 5 is used twice a day or 5 times a day? So let's start to remodel space number 1 into something similar to space number 5 and get it utilized, or just abandon that property altogether. We don't need that much space, right? We're not using it, so let's not pay for it. So it becomes a method of sort of cost optimizing your real estate assets as well. So there's a lot of really great benefits to the data and analyzing it correctly and bringing it in. We see a lot of preemptive maintenance or prescriptive maintenance pieces where we can actually sense the current going into a motor for a large piece of equipment. And as that current starts to creep up, we can actually use that, the artificial intelligence, the data infrastructure, and determine that piece of equipment is destined for failure or needs maintenance or has something going on with it. So you can actually prescribe that maintenance and have someone go out and work on it instead of waiting until it fails and then rushing to get it done and complete it when the large pump or compressor or whatever is not necessarily stored in the basement ready to be replaced right away. It's usually quite a scramble to make that happen. So preventative maintenance has been a big thing for us. And then eventually sort of looking towards the future, like Trevor mentioned, part of these systems will start to even count people. So for emergency situations, if we had an emergency in this building today, they would know that there's X amount of people in this room, and they know that there's that many people in the room next door, and they can quickly analyze that data to know whether or not how to allocate resources and dedicate the different pieces of that. So there's things that the sensors are providing this data for that we haven't really fully realized yet, and so it's going to be really interesting to see kind of how that comes together. So, companies like IBM are using all this information to provide this sort of unheard of granularity that will continue to grow and become an interesting thing with stuff.
Watson.
Watson is one of our partners and has done a great job for us and has really created this sort of cognitive building instead of something where you've got a building that just does what it's scheduled to do and what it's programmed to do. The cognitive building can actually learn from the occupants and make adjustments as it goes, and utilizing some of these devices like the Raspberry Pi or the BeagleBone Black for gateways to gather the information is pretty interesting. So yeah, it's been a fun ride to see it sort of all coming together. So, and we bring a lot of this together. In retrofits, it's hard to wire all these sensors. The more sensors you have, the more granular your data, the more you can do with it. And so that's where we found that the wireless devices are sort of driving a lot of the installations. And then it gets into the issues of battery life and other things. And so EnOcean as a company has about 1,500 different self-powered devices. So we utilize a lot of the different self-powered mechanisms. We use the lights in the space to power different things. And then we use some different kinetic energy harvesters and a variety of other pieces that way. So yeah, so we're looking forward to see where it goes. So I'll hand it off.
Okay, thank you very much, Troy.
Thanks.
Thanks. And George is going to pick up on those hardware cues as well. So, George Thomas, Contemporary Controls. I don't know how many hats he wears.
Yeah, we're a few other guys. George Thomas, Contemporary Controls. I guess my side job would be IEEE and the Life Senior Member there and History Committee. So the older you get, the better history is. And nobody can challenge you after a while. So anyway, I guess from a hardware point of view, we're a hardware company. We look at gateways, routers, and controllers. And from a hardware point of view, the IoT Edge thing is kind of a scary moment for hardware manufacturers. Because of the fact that there's different platforms that are available, they're very powerful. In this term IoT, we usually ridicule anybody who says about IoT, what is it? Well, what's ever in your mind, how you want to view it and how you want to use this thing. And I see the term edge and IoT being linked together, one and the same thing. And John will correct me on anything I make a mistake on, but anyway. And one of the things is I see small devices, maybe a single point bringing up information, and I hear see the more powerful Raspberry Pi, BeagleBone class of micro PCs. And they're going to have an impact on our business, I feel. So we just made a device that had like 6 in and 6 outs, just to get an idea from you guys what you want to do with it. I didn't put it, they had no application in there. How do you want to see it? And we get all kinds of ideas. I want 3 points on the chiller, to go back to the chiller OEM, to say how the chiller is doing. We don't want to give that data to the customer. There's all kinds of ideas out there. By going from edge to cloud, which bypasses our traditional model of a controller being, let's say, a server, going to a middleware, going to maybe a supervisor. So it's very disruptive. It's disruptive hardware and software. So from we're looking at these micro PCs, we call them. The other thing too is one area we're still missing, I feel, is what if there's no BMS system? We talk all about BMS. You never talk about the situation. When you fly into O'Hare in Chicago, you couldn't do it this one trip. It was all cloudy. I always look at the rooftop units. All those rooftop units out there got economizers on them. And I guess how many of those economizers are actually working? I would say at best 50%. And then in California, we're supposed to be monitoring the efficiency of economizers, and there's no BMS in the system. So how are you going to do that? One thing you can do is put a bunch of sensors in the RTUs, and you can push them up to the cloud with a low-cost device. That is one thing, and let your analytics determine what's going on. In terms of like the economizer, the points you really need are in the RTU. They're not down at the thermostat. You're going to get a mixed air temperature. You need that. There's a couple parameters. You may want to know how your refrigeration is working in your DX. That is basically better to do in the RTU itself. How you get that data out of that with a non-BMS system is tricky. If there was a way to do it with Wi-Fi or some of the others, technologies like that, you can get that data. So one of the areas of IoT from my point of view is non-BMS. And there's so much of that out there.
What system would that be if it wasn't BMS?
It means RTUs and thermostats, period.
Okay.
And they may not even be communicating thermostats. But if you have them up there in the RTU, you put equipment in there, you can get more data.
Yes,
And
sir.
by having the data, you can find out, is that economizer working? It could also be information to the owner. It's a benefit to the owners. And it's also a benefit to the troubleshooters that have to take a truck out to do troubleshooting. And they don't like windshield time. So I see that as one area of IoT that is maybe not really considered fully. All right, but John will tell us all about how we do it in the big building, but I'm saying there's one untapped area, and I think it's small buildings. Thanks.
Thank you very much for Sky Foundry and Meet Staff.
Okay. Thanks, Ken. Yeah, the two hats I wear that are relevant to this crowd are Executive Director of Project Haystack. And in that role, we're trying to help people more efficiently utilize data so that we can take greater advantage of the data that's being made available by smart and connected devices, Internet of Things devices. And in my day job, our company is Sky Foundry, and we make analytic software to look at the data and derive value from the data by identifying patterns and issues and faults and stuff. So, hearing some of the comments and stuff, one of the things I'd like to start out with, I've had the opportunity to participate in this session since Ken started, about 5 years ago? 6?
Yeah.
5.
It's our sixth, I think.
Sixth, okay. And, from a pattern recognition point of view, there's usually themes, right? And if you go back 2 years ago, one of the big themes was cloud. Last year we were talking about productivity of, the whole concept of 330, 300, if you're not familiar with it, right? It costs $3 a square foot to build a building, 30 to run it, and the value of that space for the human being is producing $300, right? And are we spending enough attention on that? A couple of years ago, the cloud, and of course this year, the edge, right? And I think people say, oh, wait a minute, the edge, we've had microprocessors and devices out in the field, so what's new about the edge? And I think the way you need to look at it is the edge is a concept of where you're doing things and generating value, okay? So we've had a lot of conversations and activity around high value add applications, analytics, using data, how much value you can derive out of that data. And that started only being available at the cloud level. The software had to run up in the cloud to do that. And when we talk about the edge, now we're saying, well, you know what, that same analytic capability can run all the way down at the edge device. And we're talking about where you're running value-added applications.
Right.
Okay? So yeah, there's processes at the edge, but now we're running more and more, like Troy's mentioned, we've got an infrastructure with more capability, more processing power, and we can run more applications down there. So that's what I think, to me, that's what the edge means. It's enabled by micro PCs, but it isn't the micro PC, it's what you're doing with them down at the edge. if all you're doing is reading a value and putting out a temperature, well, we've been doing that for a long time. It's useful, it's at the edge, but that's not what I think the concept is. And so I think that's the opportunity that we're seeing that's affecting the industry. You see it on the floor out there, you see manufacturers either building products, deploying products, or trying to figure out what will this mean. But one of the biggest potential values of the edge is when those edge devices are open for deployment of applications. I have an iPhone, I want this application on it, I can put it on it. If I have a rooftop controller, what if I want an application on it that I like? Can I put it on there? The processor power today, the answer is yes. Does the industry enable that yet? I said by and large the answer is no, but you're seeing new open platforms. George mentioned you have an open platform that people can pick applications to run on within the capability of the device. I would say that in many cases you don't have the ability because those products aren't open. They may be open for communication on protocol, but they're not open for me to choose what apps. But yet everything else happening in the Internet of Things in the consumer side allows you to do that. I can assemble the controls I want in my house, right? I have to pick from one of 3 different families, but I still have a tremendous amount. And I think that's what we're talking about the edge and how it's going to affect buildings, is we're going to be able to bring applications that we care about throughout the building from the cloud to the intermediate layer down to the edge. So I think maybe that helps in people understanding, what we're meaning by the edge. It's a concept of where we're deriving value, where we're running processes.
John is saying, you're saying the edge, the definition is where the calculations are being made. Wait, is that correct?
We're doing calculations with a temperature sensor, right? It was simple. It's where we're running value-added applications, right?
Because I'm wondering, if you are to the cloud, I would assume you want, if you had like a cellular connection, wouldn't you want to reduce all the calculations down lower? I think that would be the better, the model.
Well, there'd be some reasons you want to do that, right? One is lower costs for communicating the data, right? Less bandwidth usage, less payment to Verizon or AT&T. Those are reasons to do it. You might also have a reason you want more real time. I need to make a decision down here faster than the latency to get at the cloud. The good.
I'm just curious where you think it's going.
I think it's too early to tell. I think you see most of the innovation is not coming from the bigger players, right? It's coming from the smaller players, and then like industrial change would be the bigger players that'll consolidate and take it over, and and there'll be 3 phone manufacturers, there'll be 3 cloud players. But how many years is that going to take? And that's certainly not the people who pioneered these services that are monitoring buildings, performing analytics, optimizing buildings. You're starting to see the majors come into it, tell stories about it, etc.
This open hardware, open software question, right? That's kind of interesting. But if we look at what we're going through in the consumer world right now, so I bought my son for Christmas. He's 13. I bought him an Alexa, right? An Echo. How many of you have an Echo? Yeah. So virtual assistant gift in here, but certainly you start to realize, okay, well, should I buy an Echo? Should I buy a Google Home? Should I wait for, Apple's HomePod to come out? Which one of those do I want to buy? And you start to think about, okay, what decisions I'm making on, a hardware platform, because that hardware platform is tied very closely to this walled garden, right? So, for instance, the Echo will work with, some devices outside very nicely. It works with my Nest thermostat, it works with Cube, right? But those devices have to be part of kind of that walled garden infrastructure. So I think, we've looked at this, certainly when I started, I've gone through this kind of open systems revolution, LAN and backend and all that. We're kind of redefining that right now, right? Almost everybody offers, a backend solution, right? Just kind of standardized data. But, what are we going to be talking about a year, 2 years from now when we've got kind of these devices, we're calling them edge devices, just, bigger computers in a box that are controllers as far as I'm concerned. But, how are we going to enable really or break down something from being a walled garden that's very kind of manufacturer specific or ecosystem specific to really, kind of this open hardware, open software model. So just kind of a stirring thought on the fly.
A comment I wouldn't mind adding to that before Mark jumps in. I'll speak to this speaker. And in some of our pre-sessions, we started talking about the voice of the industry, this whole idea of the Amazons, the Google Homes. And what's happening is the price point of that stuff is dropping down that it is quite possible that you will actually have Alex on one side of your chair and Google Home on the other side of your chair, which I do. And so I talk to each one.
They fight.
I actually have one turn light on, one turn light off. and then the integration. But what impresses me is the integration. They're talking to the same device. But that's not the story I want to tell. The story I wanted to tell is the price of this stuff is coming down to the point that we can actually afford to have one on either side of our chair. But the next evolution of this is these companies will pay us to put their voice in our products because they want access to their chain. They want to sell the most devices, and they want the advertising content. They want you to talk to this device because you order Amazon stuff. They want you to talk to this device because you will order Google stuff. So this is kind of a different concept. I don't think we've ever had anything like that fall on top of us, where we'd actually have a product appear. And actually, can you imagine that if they would actually pay you to do that?
Sorry, this is very interesting as well. So Internet of Things also brings in, it's a big phrase, but also brings in everything from like creepy to convenient, right? So the convenience is Alexa. I'm an 80s rock fan. I'm sorry, everyone. So Alexa, please play me, some 80s rock, right? So she'll start playing the 80s rock. And then you've got this great Alexa app that goes with it. I feel like I'm working for Amazon all of a sudden. So you get this great app, and you start to realize, right? It's actually recording all of the things and registering all of the things you're saying. So, what time you turn your lights on, what your preference is for your thermostat. That's kind of the stuff I geek out all day about. But it also knows the preference for music, so it can suggest things. It knows what you ordered. So it's tying all these things together that somehow if you look at it, if you don't think about it as you're kind of using it on a moment-to-moment basis, but if you start to look at actually the amount of information you're sharing, that will go into the creepy category. So, interesting.
Very, very good caveat on what I just said, but the point is it's happening, so we need to understand it's happening and prepare ourselves. I think we left the saga. You were just starting to speak.
No, I want to hear what you're starting to get questions. Just one additional driver, and first of all, I want to echo what John said about the choice of applications. As an industry, just a thing that I believe that this year, 2008, is all about choices for system integrators, building owners, and operators. And I think part of the other driver about the edge, beside the computer processing we talked about, is how the value proposition over time has continued to evolve. Back in the day, and we all got gray, most of us got gray hair, except you have some. It was about connection. It was about the connectivity and the integration. Been there, done that. I think that is expected on every type of project today. And that was the value proposition. We can connect to anything, we can make anything integrated. Wonderful, been there, done it. Then the next evolution was interoperability. Let's make all these things interoperable. Now, as data and analytics have taken their place at the edge, value propositions have changed to more about the true operational side of a building and the financial performance and maximizing that lifetime value of all that equipment which is running. So if the average lifetime value of an air handler is 15 years, with edge, analytics, all of this stuff that we've been talking about, you might be able to get another 5, 6, 7 years out of it. So again, you got to look at the business side of what's truly helping drive edge beside the technology side. The technology side is here. It's accepting the business side.
Thank you. My name is John Kennard. I'm an HVAC contractor. So I think my question is a little simpler than probably the majority of people know in this room, but part of what kind of, I think, interests me about the panel is more of the macro question on, and I think, Mark, you said it's the Internet of Things is kind of whatever's in your mind, but how do you control that and how do you build it off of Project Haystack with everything that's out there? I assume the challenge is pretty ridiculous to try and get everyone to go on something like, or to use the language of Project Haystack. I don't even know if that's the right word, but curious to know what that challenge is and how do you attack it, and how do you break it down and try and get more people involved.
What is Project Haystack and what's the role, right? And the best way, I think, to describe it, it's a markup language, right? The reason you can point your web browser at someone's website and see what they had to say is they agreed on how they were going to mark up the data. You and I didn't have to pre-negotiate how your site's going to work so I can make sense. We need the same thing with data coming out of systems, right? You should be able to get all the data out and you should be able to understand what it is because it should be marked up with tags that describe what it is. So you don't need pre-negotiation. All of the effort that people are wasting on pre- and post-negotiation of what does this piece of data mean. It's a drag on the industry. It adds cost. It slows down opportunities. It's hurting us all. Whether you're selling products or you're installing systems or you're the building owner, it is wasted effort, money, resources. So Project Haystack is the leading approach to solve that. And it's open source and it allows people to contribute and try to address it. The biggest issue is educating people about it. So nobody has addressed parking meters yet. Nobody's addressed solar systems, whatever. Forming a working group, experts come together, and now it has a wider and wider expanse of systems. The other thing is reaching out to other standards organizations. We're currently working actively with the BACnet group at ASHRAE and another open source group called BRIC to unify all of this so we agree on one thing. You can't have 3 HTMLs. You can't have 3 markup languages for system data, right? When will manufacturers build it in? Well, manufacturers will respond exactly when they do for every other technological advance, when their customers demand it. Start demanding it today, and you'll see it in some amount of time. Don't demand it today, you'll never see it, right? But it's just one more of the things that manufacturers have to realize that in this new open world where I want to decide what applications I'm going to run on that rooftop controller, I want to also be able to get the data out in a way that it requires minimal effort. So it's outreach. You know, we reach across to the BIM community and we reach across to other communities just to bring people together. But you know, our industry doesn't move quite as fast, although HTML took quite a while before it became the thing we all had on our desks, right? It was out there for a long time before that. And Haystack, it'll be similar. But you see tremendous progress, and the fact of the effort of these groups working together is a very positive sign. Everyone wants to solve this so we can move on to where the value is. There's no value in this. There's cost, but there's no value. We just want to be able to get the data out and understand it. So it's about the best answer I can give for you.
That's one of the most succinct descriptions of Haystack I think I've heard. So
You don't give me any damn time to.
Yeah. Speaker number 2.
Hi. My name is Rick Staymeyer. I'm from Burlington, Vermont. I'm a controls nerd all the way through and through with a computer science degree academically. My question, first off, is I want to commend Contemporary Controls for grabbing the Raspberry Pi and turning it into an HVAC controller. That's huge. My question is along the line of what John was just saying in terms of getting people to agree. Currently, the business model is that you buy controls from manufacturer A, and with that control platform comes a software programming environment and a front-end environment that is made by the same manufacturer. With the advent of these micro PCs that are leveraging Linux and programming languages like Python, and their entry into the market, which is inevitable, do you guys see the future of controls being more of a less proprietary programming standard, an opening of all of that so that, you know, air handlers are now programmed in Python using open source PID loops that run on a fundamental algorithm we all agree upon, as opposed to having the PID loop from manufacturer A, you know, and the PID loop from manufacturer B, and they have different inputs and they generate different outputs. Do you see that unification on the horizon through these micro PCs?
Yeah, I guess so. All right. Agreement in this industry, very difficult. So I cannot see Johnson or Schneider or these guys pursuing an open standard. But I can see a groundswell of things pursuing a standard, course, we were promoting the Sedona as an open, because it is open, and it's an academic free license. But I'll also mention there's an initiative through, there's Berkeley Labs has got an initiative with Project 36 with ASHRAE and on sequences. I would suggest you look at that. And then there's also taking those sequences and putting on, there's an open control project with Berkeley Labs. And I've heard about it. They want to do modeling, simulation, improving both sequences and have an open platform. I don't know if I'll see that in my lifetime, but it's certainly the thing in the right direction. Maybe something will come about it. In terms of Python, I don't know. I guess you got to have a drag and drop mentality, and then you have a structured, line code and so those two religions will never come together.
Hi, my name is Jay Xu. I am working for a startup AI company here in the industrial area. So I'm very, very interested when you guys talk about productivity. That's a very typical AI question. So my question will be, even though you guys talking about 330s and 3 rules, but in the end of the day, you go to the end customer, they talking about ROI, right? So how do you guys actually quantify this as to tell the customer what's the ROI? That's my question for productivity.
Well, first of all, there's multiple ways to look at ROI. So if we look at our traditional way we've evolved as an industry, it was, at one time it was popular about energy. I'm going to save you this much in energy usage. I'm going to save you this much in energy dollars. Then it goes to reduce truck rolls, as an example, where there's an issue been identified, the truck goes, spends an hour to get there, they find out, oh crap, I don't have the part, they go all the way back, figure out, oh, then they go back again. So there's multiple ways, but one of the newer areas that at least I've seen, I think many people in here, is the wellness and productivity side of it within the environment itself. So common sense tells us that a properly comfortable work environment will make us work longer, harder, better, whatever, and make us more productivity. Lighting will also contribute to that. There are brand new studies, and I've never believed that. However, I'm starting to see studies that are quantifying all of that right now. So especially with AI, I think that is one of the biggest values that AI can bring, is helping to, quantify and do things with respect to productivity and comfort. If you're looking for a study on there, Harvard just completed one, which is a very good study out there that does quantify the productivity and the wellness side. But back to your question, sorry, I'm rambling a little bit and I'm passing on. It's ROI can be measured in how you want to do it. In other words, what is the specific thing that the building owner and operator is trying to get out of it? Is it, I want to save money, I want to extend the life of equipment, I want to make all the occupants operate more productive, I want to do all of that. So there's not one thing for ROI. And in our industry, that has been something that I think has always been hard to completely define, because it's in the eyes of the beholder.
Yeah. Two other components of that, it's been, and studies are out to prove it, that efficient buildings have a higher asset value. And that can dwarf the energy costs by increasing the asset value, and they rent at higher rates and typically have a higher NOI, net operating income. And there are studies that show that. Now that may not be enough to sway some owners, and it only works if there aren't split incentives, right? So the developer owns a building, may care about the net asset value, right? So, the different ROIs apply to different customer types and what their financial interests are, but there are numerous ROI, provable ROI points to run our buildings better.
And just to add to that point with respect to the asset value, 3 years ago I was on a global tour and I went out with a big property owner in Hong Kong. We're driving around and he's showing me all the different properties that he owns and whatever. So we get to this one area. He says, take a look at those buildings. Tell me what you see. I looked up. I think they were 20 stories each. Basically identical buildings. Absolutely. And he says, I said, well, who's in there? Well, it's both are owner occupied. So, I'm sorry, rental. And he says, we just sold those. And the one building on the left, which had, let's just call it intelligent building technologies, and fill it in the blank, sold for $5 million more than the one on the right, just because they were able to have all the information, all the data. So in that case, to John's point about asset value, you're increasing that asset value of a building with that.
So Paul Nelson, I'm a product manager with Johnson Controls, and I'm very interested in the idea that edge computing could mean the end of sole sourcing from a single manufacturer, your BAS system, and the end of proprietary protocols. So knowing the amount of quality control that goes on within a single manufacturer, how would we replace that guarantee of interoperability? Do we see that as, for instance, happening in increased commissioning efforts or compatibility listings?
How many different manufacturers are involved in me pulling up a website on this? I don't see that as a problem. I see it as something, hey, I got a thing there. Right? How many routers go? Juniper routers, Cisco routers, this routers over this protocol is coming to an apple. This is just making the individual components of high quality and reliable and having proper standards for the communication. I don't see that as a barrier myself. I really don't, right? And if those things work individually on their own, then we can combine them into systems, just like virtually everything else on the planet except automation systems.
That was the mic drop.
So, but let others respond, and I'm sure there's a debate on that.
Yeah.
There's nothing to say you still keep your BACnet compliance, your BACnet retail listings and everything else. If it was just a question of communications, and you can keep it down there, you can keep your standards. But nobody's looking out for trying to get another compliance here. So I don't think it's the end of BACnet or anything like that. But there's going to be communications, I feel.
I think, just to comment on this, I think customers don't buy, widgets, right? We're an industry that loves to buy widgets, a bunch of technical geeks. But, at the end of the day, again, tying the capabilities of system and all our components into a solution to the customers, you're going to deliver the end customer as the end game, right? And whether that's with, open source components, maybe I'll see that, in my tenure of my career. But customers are going to buy a programming environment that is the easiest, that provides the best total installed cost, that can be serviced by multiple vendors, that they want choice. So buying a solution, right, that ticks all the boxes. You have a Raspberry Pi and Python script satisfies that. Well, it's fine. It does at the moment because to your point. There's a lot of kind of know-how that goes into stitching these solutions together to make it best install cost, best of breed, etc.
This is Anto from Anchor Labs. So my question is kind of getting back to the standards sort of issues. And the point is that standards are not just things that are agreed upon by standards organizations, right? I can write a Word document right here and send it to anybody in this room, and you can all open it and get the meaning of what I'm saying. Right, so there's lots and lots of standards like that. I don't have to go through them. I guess what I'm interested in is what kind of standards that are like that become an inflection point for change, right? And if I look back to the PC, the sort of personal computer sort of era, I would wind it back to 1980 when MS-DOS came along, right? Because before MS-DOS, there were all these computers doing all different operating systems, doing different things, and people were writing different software specific for each operating system. And then MS-DOS came along, right? There was a bit of luck involved with Bill Gates and IBM. And overnight it became a standard whereby devices could be created with BIOS that was then reverse engineered. And then people could write software like Lotus 123 that not just focused on one particular vendor of hardware. So the question is this kind of a potential trajectory of what we could see in building automation systems?
Can we get security, please?
Yeah, right. Security, please. I think, and honestly, I think this comes back to kind of, this idea of these different walled gardens, right? So right now we very much have walled gardens. We've got open protocols that, communicate between these systems, but we still have, tool sets that are kind of locked down, between different vendors in many cases. So I would say that this concept of open hardware, open software, creating an environment where not one of us as a manufacturer is going to build everything, right? Creating an environment where others can use either a software development kit like we have for the mobile environment to really build some of these solutions in and make them very, very easy to deploy. If I was to guess, I would say that's generally the long-term trajectory where we're going.
Okay.
This is something that we as a manufacturer of end devices, the sensors and the different pieces that are actually feeding the data back into the network, we struggle with this all the time because we supply sensors and different pieces to Distech, we supply them to Reliable Controls, we supply them to Delta Controls, and each one does it a little bit differently, right? So we as a manufacturer of sensors and equipment that's feeding the data in, we struggle with this a lot because we have to decide, okay, Distech wants it this way, Reliable needs it that way, Johnson Controls needs it this way, whatever. So we're very hopeful in some of these different things that are bringing these into that sort of Word or MS-DOS type thing. Hopefully it's not DOS, but something where it is one particular thing that brings it together and sort of brings it all forward. And then we're able to, as a manufacturer of these sort of the leaves on the tree, we're able to feed back one thing, and that's all we care about, right? We don't have to necessarily say, okay, well, this is for them, that's for them, that's for them. And we've done a pretty good job of that with our Ocean Alliance, which is, again, this group of people that are coming together, and it's one more thing where everybody's got to kind of come together and agree on how it's communicated. But then each person interprets that communication in their own way, right? So I think if we could get that edge computing to all roughly agree on a platform, I think that would be extremely helpful for the industry to innovate and really drive some momentum forward and see some more benefits out of those capabilities that we have.
I just want to point out to Angela, there's somebody ahead of DOS, and that was CPM for Digital Research. And that
which was better than DOS.
And that story is even more interesting, how he blew it with when IBM came to visit. So.
Yeah. Maybe some of those problems you were discussing will be solved by open platforms. If we start to all move to more open platforms, then the operating systems will be more similar. So that might help us a bit.
Sure.
Tom Kennedy, I'm a zoning engineer, but I come from the mechanical side, so I'll display my ignorance. We have automated cars coming, we've got drones, we've got smartphones, we're using the airways a lot. So if we start putting bazillions of these things on rooftop units and all these different devices inside the building, how confident are we that reliably they'll continue to communicate?
I'm going to say myself, that's not something I can answer. There's people at Qualcomm and other companies worrying about that and worrying about how, we can all get on the internet in this room, or when you land the plane and everybody turns on their phones at the same time. What does it take, 15, 20 seconds and I'm getting my email? So someone else, I believe, other than anybody on this panel is worrying about that. I don't know what struggles they're going through or how worried they are about that. I don't hear much about it. So.
And that's a good argument for doing your analysis in the edge and not in cloud. So because you just hold on your data. It's like taking trend data. You can store your trend data for a day, hour, whatever. You don't want to lose that. You push it up the cloud and you get a chance. So there is a strategy to do that, to assume you're going to lose comms at some point.
And so all of our devices are wireless, and that's definitely something that we've spent some time thinking about is how the wireless RF spectrum is impacted by some of these different things, especially the switch to 5G or 5 gigahertz on Wi-Fi, which is a big thing that's coming. But we spent 2 weeks ago at the Consumer Electronics Show in Las Vegas, and so every single person there has a Bluetooth headset. They have Bluetooth in their phone. They've got their laptop, which probably has Bluetooth in it. Then they have Zigbee devices, and then everybody has Wi-Fi, right? So it's a really good case study for massive amounts of communication. And so we were demonstrating 3 different pieces of equipment there. We had one that was a Zigbee communicating device. We had one that was a Bluetooth communicating switch, Zigbee switch, Bluetooth switch, and the Enocean switch. Zigbee and Bluetooth both operate in the 2.4 gigahertz world, which is obviously Bluetooth and Zigbee and Wi-Fi. And we were unable to connect our iPhones and iPads to our Wi-Fi router. We were unable to get the Zigbee switch to work. The Bluetooth switch did a better job. Again, it's sort of the Qualcomm and the Nordics method of implementing that, what makes it a more powerful connection or a better connection. But then the Enocean switches, which are run at 900 megahertz, which is a very uncrowded band as we go forward, were working great. We didn't see an impact from all the RF traffic. So I think sort of making those choices, one, it's good to do a lot of your computing locally because you can't count on that connection all the time, but it's also good to choose the right wireless frequency that's not competing with a whole bunch of these other technologies that aren't really part of our thing. I mean, if we have 70,000 people in this hall, we now have 70,000 Wi-Fi radios probably running around in there. So yesterday, 2 days ago when the hall was empty, everything would work perfectly well. And then today with 70,000 Wi-Fi radios running around there, it might not work at all. And you can't count on that connection to always be there. So it is a good argument to do it on the edge at some, and then when you have the connection, make all those different uploads and connections there.
Incredibly interesting discussion. And I believe these gentlemen are going to remain for a bit of time after, and you'll probably never in your life get an opportunity like this to talk to such industry experts. I'd like you to join me in just thanking them for all of their input today.